Today we are doing more verifying of trig identities as well as doing trig proofs using those basic 8 trig identities from yesterday, as well as doing a little bit of factoring and common denominator work. So if you look at number 1, for problems 1 and 2, what do the instructions say? Review. Number 1 is a really old review. It's probably a 4th grade level math problem, 1/3 plus 1/4. In order to add two fractions together, what do you have to have? Common denominator. What's the common denominator between 3 and 4? 12. So the 3 had to be multiplied by 4 to get 12. So multiply the numerator by 4, and 1 times 4 is 4. And the 4 had to be multiplied by 3. So multiply the 1 by 3, and 1 times 3 is 3. And when you're adding fractions, the denominator stays the same, and you add or subtract the numerators. And here we have 4 plus 3, which would be 7. If your fraction would simplify, you would do so, but 7/12 does not simplify. So there's number 1. Problem number 2. Now we are still adding fractions, but now this is more algebra 2. So this is what you did in algebra 2 when you had to find a common denominator and you had binomial expressions in your denominator. Well, first let's go back to problem number 1. How did we get the common denominator of 12? We start with denominators of 3 and 4, correct? So what did we do to 3 and 4 to get the 12? Multiply. So we're going to use the same concept here when we have binomial expressions. So for number 2, to find the common denominator, we will just add, or not add, we will multiply the denominators together. So we need to multiply 2x plus 1 and x minus 3. You did this back in your rationals unit. You remember doing rational functions? You had to do a little bit of this with that unit. So again, to find the common denominator, multiply the denominators together. Now the first denominator had the 2x plus 1. So it already has this one. So what factor is it missing? The x minus 3. So that means the 3 in my numerator needs to be multiplied by x minus 3. Now for the second denominator, it already has the x minus 3. So what part of the denominator is it missing? 2x plus 1. So that means my numerator, which is 5, needs to be multiplied by 2x plus 1. Now go ahead and distribute the 3 and distribute the 5. So 3 times x is 3x, and 3 times negative 3 is negative 9. And for the second fraction, distribute the 5. So 5 times 2x would be 10x, and 5 times 1 would be 5. Now that we have a common denominator, now we can add those fractions together. So the denominator stays the same. So we keep the 2x plus 1 times x minus 3. Now add your numerators together. So what's 3x plus 10x? 13x. And what's negative 9 plus 5? Negative 4. Now I left the denominator in factored form because I was hoping that we might have a factor that cancels. So do we have any factor in the numerator and denominator that would cancel? No. So that's my answer, and we'll just leave our answer in factored form. Now we're going to put that together with the trig identities we talked about yesterday. So look at problem number 3. The instructions say simplify each expression to a single term. And yesterday we emphasized that single term means 1. So you should only have one term and your answer. So if I have tangent of x minus the quotient of secant squared of x and tangent of x, well, the first thing I could do is change tangent of x to a fraction. And how would I change tangent of x to a fraction? Put it over 1. Or you could do sine over cosine. I'm just going to leave it as 1 just to make it simpler. Now, in order to add or subtract fractions, what do we have to have? A common denominator. So what would the common denominator be between 1 and tangent of x? Tangent of x. So the second equation, the second fraction is ready to go. It already has tangent of x in the denominator. Now looking at the first one, what do you multiply 1 by to get tangent of x? Tangent of x. So the numerator has to be multiplied by tangent of x. So what's tangent of x times tangent of x? Tangent squared of x. Now that I have a common denominator, now I can subtract them together for this one. So the denominator stays the same, and we have tangent squared of x minus secant squared of x. Now the next thing I could do is, if you notice, we have a square and we have a square. So if you have terms that are squared, maybe we have a Pythagorean identity. So let's see what we might have. So if I have a tangent squared, what would I have to divide by? Cosine squared. So sine squared divided by cosine squared would be tangent squared. Cosine squared divided by cosine squared is 1. And 1 over cosine squared is secant squared. Notice in my numerator I have tangent squared minus secant squared. So if I subtract secant squared to both sides, that gives me tangent squared minus secant squared plus 1 equals 0. So instead of tangent squared minus secant squared, well, I have to get that by itself, so I would have to, minus 1 to both sides, so that gives me tangent squared minus secant squared is equal to what? Negative 1. So that numerator, instead of tangent squared minus secant squared, what could I put? Negative 1 over tangent of x, and this is a reciprocal. 1 over tangent is equal to cotangent. So this is equal to negative cotangent of x. So if you see a 1 in the numerator, it's a reciprocal. So the reciprocal of 1 over tangent would be cotangent. That's one of those reciprocal identities from yesterday. Next one, number 4. Now again, when we're adding two fractions, first of all, let's change this to a fraction. Let's put it over 1. Actually, before I even do that, let's go ahead and do a little bit of simplifying with that. Because what do you know about sine of x and cosecant of x? Yeah, they cancel each other out because they're reciprocal. So if you multiply reciprocals together, it's always going to be 1. And let me show you. Because this would be sine of x over 1. Instead of cosecant of x, what could I put? 1 over sine of x. So that cancels, that cancels. So this is just cotangent squared of x over 1 plus cosecant of x plus 1. So sine times cosecant is 1. Yes. Okay, if your paper says sine of x, cosine of x, go ahead and make that correction. So make sure on your paper, make sure yours says cosecant. So that was a mistake on your notes handout that needs to be fixed. So make sure that's a cosecant. I've been trying to fix errors as I've been moving along, but that's one thing I neglected to fix. Okay, now, in order to add these, I need to have a common denominator. So if I make this 1 over 1, what's the common denominator? Yeah, if I multiply those, I get 1 plus cosecant of x. So the first fraction's good. It already has the common denominator. And what do you multiply 1 by to get 1 plus cosecant of x? 1 plus cosecant of x. If I multiply the 1 in the numerator by 1 plus cosecant of x, I get the same, 1 plus cosecant of x. And this is equal to 1. 1 plus cosecant of x divided by itself is equal to 1. And now that I have a common denominator, now I can add them together so the denominator stays the same. And adding the numerators, we get cotangent squared of x plus 1 plus cosecant of x. What should you be thinking right now? Yeah, Pythagorean identity. If you see a 1 with a term that is squared, there's probably a Pythagorean identity. So let's see. Sine squared plus cosine squared equals 1. If I have cotangent, what would I have to divide by? Sine. So divide everything by sine squared. So sine squared divided by sine squared is 1. Cosine squared divided by sine squared is cotangent squared. And 1 over sine squared is cosecant squared. So over here, I'm going to circle this. And instead of cotangent squared plus 1, what could I replace that with? Cosecant squared. So this would be cosecant squared of x plus cosecant of x over 1 plus cosecant of x. Can the cosecants cancel? No. In order to cancel binomial factors, you'd have to have the same binomial in the numerator and in the denominator. But here's another thing. Yesterday we talked about trigs can be factored. So if you get stuck, if you don't have another Pythagorean identity, and I really don't want to do sines and cosines because then I'd have a complex fraction, and that makes things more complicated. So is there anything that will factor? Yeah, notice this is cosecant squared, this is cosecant. They have a common factor, so take out the GCF. So the GCF would be cosecant of x. So factor out the GCF. So cosecant of x, what do you multiply cosecant of x by to get cosecant squared? Cosecant of x. What do you multiply cosecant by to get cosecant? 1. That's helpful because what happens now? Yeah, now we have the same binomial. We have cosecant of x plus 1 in the numerator, cosecant of x plus 1 in the denominator. So you can only cancel binomials if you have the same binomial in the numerator and in the denominator when they're being multiplied. So my final answer is just cosecant of x. And notice my answer is a single term. So that one was lengthy, but we made it. Next one, problem number 3, we have tangent of x plus cotangent of x, and that sum is being divided by secant squared of x. Now, looking back at these other questions, how many terms were we given? 2. We're given 2. But over here, how many fractions do we have? Just 1. So what you could do, you could break this up into separate fractions. So what I mean by that is both terms in the numerator need to be divided by secant squared of x. So that means tangent of x needs to be divided by secant squared of x, and cotangent of x needs to also be divided by secant squared of x. So if you have one fraction, you can break it up into its 2 parts. Now, what do you think I should do next? Yeah, convert everything to sines and cosines. So instead of tangent, what could I use for tangent? Sine over cosine. Instead of secant squared, what could I use for secant squared? 1 over, not 1 over cosine, 1 over cosine squared. Don't forget that square. Now instead of cotangent, what could I use for cotangent? 1 over tangent, but I want everything in terms of sine and cosine. Yeah, so use cosine over sine. And we already said instead of secant squared, make sure it's 1 over cosine squared of x. Now we have complex fractions. We have a fraction over a fraction. So when you're dividing by a fraction, how do you divide by a fraction? Multiply by the reciprocal. So that means sine of x over cosine of x needs to be multiplied by the reciprocal, which would be cosine squared of x over 1. The second fraction, cosine of x over sine of x, needs to be multiplied by the reciprocal, which is cosine squared of x over 1. Now, we do have things that cancel. Cosine of x in the denominator will cancel with only one factor in the numerator. So that will leave us with sine of x, cosine of x, plus, here, I'm going to have a sine of x in the denominator, and when I multiply the numerators, this is actually cosine to the first power. So what's cosine to the first power times cosine to the second power? Yeah, cosine cubed of x. So when you're multiplying, make sure you add the exponent. So 1 plus 2 gave us a 3. Now, we still have fractions. So in order to add fractions, what do I need? Common denominator. So we're not finished. I'm sorry. What's the common denominator? Sine of x. So what do you multiply 1 by to get sine of x? Sine of x. So that means the numerator needs to be multiplied by sine of x as well. So we need to multiply sine of x times cosine of x. So sine times sine would be, so this would be sine squared of x cosine of x. Now we have a common denominator, so now we can add the numerators. Keep the common denominator. Adding the numerators, we have sine squared x cosine x plus cosine cubed of x. So we've already changed everything to sines and cosines. There's not any Pythagorean identities there. So really the new thing for our toolkit for today is factoring. So if you've done the other two tricks, if you changed everything to sines and cosines, if you've looked for a Pythagorean identity, the next thing is see if something will factor. So can anything factor there? Cosine. Notice in the numerator, both of them have a factor of cosine in common. So factor out cosine of x in the numerator. Would we cancel first? Good question. No, because this sign is attached to a binomial, so you cannot cancel part of a binomial with a monomial. Okay, so factoring out the cosine of x, this would be sine squared of x. And what would we multiply cosine by to get cosine cubed? Oh. Yeah, sine squared plus cosine squared is equal to 1. I'm just going to put a line through that and put a 1. So this is just cosine of x over sine of x, which is equal to cotangent of x. So now my answer is a single term. So we finally finished that problem. I'm sorry if you ran out of room. Okay, three more. Oh. I'm trying to speed up the process, looks like. Okay, for the last three, it says simplify the left side to equal the right side. So you have to start with the left side and work with the left side only. So for the left side, we have tangent of x plus cotangent of x. What do you want to do first? Yeah, change everything to sines and cosines. So instead of tangent, I could use sine over cosine. And instead of tangent, I could use cosine over sine. I want you to go ahead and finish problem 6. In order to add two fractions together, what do you have to have? Common denominator. So if you multiply the denominators, cosine times sine would be cosine sine, and you could have written it as cosine sine. But if you look at the right side, how do they have it written? Sine cosine. So I'm going to leave it in the same form as the answer. So instead of cosine sine, I'm going to write it as sine of x, cosine of x. It doesn't matter. So make sure at the very end you have this. Make sure at the very end your final answer has sine first. Now, the first fraction has the cosine, or the first denominator has cosine, so which part was it missing? Sine. So I need to multiply sine of x by sine of x, and what does that give me? Sine squared of x. second denominator has sine, so which part was it missing? Cosine. So the cosine in the numerator needs to be multiplied by cosine, and what does that give us? Cosine squared. Now I can combine them into one. So that has sine squared plus cosine squared, which is equal to 1 over sine of x cosine x. So that was our Pythagorean identity. Sine squared plus cosine squared is equal to 1. Now again, for your final answer, make sure your final answer, it has sine cosine and not cosine sine. So your final answer has to match what was on the right side. Next one, number 7, start with the left side. We have secant of theta plus tangent of theta, and that sum needs to be squared. Now yesterday we talked about the shortcut formula when you are squaring a binomial. Remember, if you have a plus b squared, you square the first time. No, it's not c squared. Square the first term. So a, when you square it, you get a squared plus 2ab plus b squared. So let's use the shortcut. Take this secant and square it. That gives us secant squared of theta. Multiply these, you get secant tangent. And when you double it, you get 2 secant theta tangent theta. Plus, take the last term and square it. So tangent, when you square it, we get tangent squared of theta. What could I do next? Yeah, change everything to sines and cosines. So instead of secant squared, I can make this 1 over cosine squared. And I'll make this 2 over 1. And instead of secant, I could change that to 1 over cosine. Instead of tangent, I could change that to sine over cosine. And instead of tangent squared, I can make that sine squared over cosine squared. Now let's go ahead and multiply that in the middle. So I have 1 over cosine squared of theta. Multiply the numerators. 2 times 1 is 2. 2 times sine of theta would give us 2 sine of theta. Multiplying the denominators. What's 1 times cosine times cosine? I like that. It's a common denominator so far. And looking at the last one, it is a common denominator. So now that we do have a common denominator, we can go ahead and add everything together. And when I add the 3 numerators together, I'd have 1 plus 2 sine theta plus sine squared of theta. I'm going to write it in standard form, so the highest power first. So put the sine squared first. So this would be sine squared theta plus 2 sine theta plus 1. Now, if you have a trinomial, see if you can factor it. Yeah. Yeah, we could write it as x plus, not x plus 1, sine of theta plus 1 squared because it's a perfect square trinomial. Or I'm going to write it like this, sine of theta plus 1 times sine of theta plus 1. Means the same thing, right? Now, I'll leave it as cosine squared of theta for right now. But is that what our final answer needs to be? No, in my final answer, in my numerator, I should only have one of these. So somehow I need to be able to factor out or cancel one of these factors in the numerator, and in order to cancel it, I'd have to have that down here in the denominator. So we have to do something with the cosine squared so that we can get a factor to cancel. So what could I do for cosine squared? Think about yesterday. Sine squared plus cosine squared equals 1. Instead of cosine squared, what could I put? Not sine squared plus 1. 1 minus sine squared. I would have to subtract the sine squared to both sides to get cosine squared by itself. So down here, instead of cosine squared, I'm going to leave it as 1 minus sine squared. And now, can that denominator factor? Yeah, what is that called in the denominator? Difference of squares. So in the denominator, I'll have 1 plus sine theta times 1 minus sine theta. What happens now? Yeah, one term or one factor in the numerator will cancel with the 1 in the denominator. So when I write my final answer, make sure your final answer matches with what we were given on the right side. So should I leave it as sine of theta plus 1 in the numerator? No, I need to change it. With addition, the commutative property of addition, I can switch it. It means the same. So I'm going to change this to 1 plus sine of theta over 1 minus sine of theta. So we have now proven the left side equals the right side. Took a long time, but we made it. Okay, one more. I want you to do problem number 8. Prove that the left side is equal to the right side. Problem number 8. 1 over 1 minus secant of x plus 1 over 1 plus secant of x. You need to show that it's equal to negative 2 cotangent squared. In order to add two fractions together, what do you have to have? Common denominator. And when you multiply these, I would just leave it in factor form. So we need to have 1 minus secant x times 1 plus secant x. Now looking at the first denominator has 1 minus secant x, so it's missing the 1 plus secant x. So when I multiply 1 times 1 plus secant of x, I get 1 plus secant of x. The second denominator has 1 plus secant x, so it's missing 1 minus secant of x. So when I multiply 1 by 1 minus secant x, I get 1 minus secant x. And now that I have a common denominator, I can combine them together. So if I add the numerators, what's going to happen? Yeah, 1 plus 1 will give me 2. And what happens with the secant? Yeah, positive secant x, negative cosecant x, there's 0 pair. They go away. So that gives me 2 over, I'll go ahead and multiply these. So when I multiply those, I would get what? 1 minus secant squared of x. If you see a 1 with a term that is squared, you should automatically think Pythagorean identity. So sine squared plus cosine squared is equal to 1. If I have a secant, what do I need to divide by? Divide everything by cosine squared. So that gives me tangent squared plus 1 is equal to secant squared. If I subtract 1, that gives me tangent squared is equal to secant squared minus 1. So instead of 1 minus secant squared, what could I put? Oh, I messed up. We didn't want secant squared minus 1. What do we want? 1 minus secant squared. So let me correct that mistake. We want 1 minus secant squared, so I should have subtracted secant squared to both sides and subtracted tangent squared to both sides. So that would give me 1 minus secant squared is equal to negative tangent squared. So to correct it, instead of 1 minus secant squared, I need to put what? Negative tangent squared. And hopefully you recognize this is a reciprocal. This is actually 2 times 1 over tangent squared. If I had 1 over tangent squared, that would be equal to cotangent squared of x. And then my coefficient out front, we have a 2 and a negative, which would make it negative 2 cotangent squared of x. Hopefully you could recognize that that was a reciprocal. If you didn't, that would be fine. You would just have changed tangent squared to sine squared over cosine squared. So that would be sine squared x cosine squared of x. And when you divide by a fraction, you would multiply by the reciprocal, which would be cosine squared of x over negative sine squared of x, which would give us 2 times negative cotangent squared of x, which would give us negative 2 cotangent squared of x. So if you notice, if you have a constant in the numerator and then you have one of the trig functions in the denominator, you have a reciprocal function, and it would have saved you a bunch of work. Okay, that's all.